So in this video, we'll be focusing on how to plot linear equations or straight line graphs on a set of axes. Now we'll be going through the general notes of how to recognize the shape of an equation before you even plot it, and going through some common example questions that you're more likely to get in both class, at home, or in exam papers. Now there will be some notes in the description below along with a worksheet for you to practice everything you've learned in this video. Now before we move on to actually plotting a straight line graph or straight line equation, as we say, it's really important that you recognize what the graph should actually look like before you actually start plotting it. So let's have a look at when you've got an equation where it's just x equals a number. So for example, if I had an equation that looked like x equals 4 or x equals minus 5 or x equals minus 2.5 or x equals 0.5, you can see here that we've just got x equals a number. Now when you have got this particular type of question, then your line will always be a vertical line, so it'll always be going up and down, and it will actually go through the value which is given. So for example, if I was to draw x equals 4, then that's just going to be a vertical line, and that is going to go through x equals 4. If I had to draw x equals 5, then that again is going to be a straight vertical line, obviously being drawn with a ruler, of x equals 5, and if it starts moving into negative numbers, then x equals minus 2.5 would be where minus 2.5, so that would be the point there, and that would be x equals minus 2.5, and x equals minus a half would be a line that goes through minus 0.5. Now the key thing to note is that as we have dealing with vertical lines, that we can actually call the y-axis x equals 0. So from this, x equals 0 is also the y-axis. And this usually comes into play when you're dealing with reflection on a graph. So let's have a look at another one. So let's have a look at, so when you've got, don't know what that is. So when you've got an equation which is just y equals a number. So for example, let's have y equals 8 or y equals minus 5, let's say, y equals 6 or y equals minus 2.5. Now with this, it's always going to be a horizontal line, so it's either going to be going from left to right, and it's be going through the y-axis through the point given. So y equals 8 would be a horizontal line that goes through 8, and again I strongly recommend that you use a ruler when drawing these lines. And y equals minus 5, well if minus 5 is here, then it's just going to be a horizontal line, and that's going to be y equals minus 5. And then y equals 6, again it's just going to be a vertical line, a horizontal line rather, through 6, and that would be y equals 6. And if we had a negative number, so if this point here was minus 2.5, then this line would represent y equals minus 2.5. And like we did before, that when you've got y equals 0 is also known as the x-axis. So any horizontal line would always be y equals and whatever number it goes through. Any vertical line will always be x equals and then whatever value it actually goes through. Now when you are dealing with an equation where it's got a single x and a single y, which is really, really important. So let me just go back to that. So here when we've got any equation that's got a single x and a single y, then that represents a diagonal line that you're going to need to be plotted, and that usually follows the format of y equals mx plus c. Now I've got a couple of videos that will link to this formula, whether it's from a graph or from an equation, but generally speaking any diagonal line will follow this sort of format. And again I'll just do a quick refresh where m is the gradient or the steepness of the line, and y is the c rather. And that's gone. And c is the y-intercept, where it crosses the y-axis. So it's always important that you recognize these key things. So for example, a question with a high a big m value. Now what's classed as a high m value, it's entirely up to you, but the bigger the m, the steeper the line's going to be. So if you imagine like you're going to slide down a hill or climb up a hill, the bigger the number, the steeper the hill's going to be, and the faster you're going to fall down it. Obviously, touch wood, you don't get injured. And then c is basically the value along the y-axis of where the diagonal line will cross that blue line. So if it's c is positive, it's going to be somewhere along above the x-axis, and if c is negative, then it's going to be somewhere below the x-axis. And again, it's probably worth writing down. So if negative line will cut below the x-axis, and if positive line will cut or intercept above the x-axis. So you kind of tell whether you plotted it right. Now again, when dealing with the gradient, so m, if m is positive, then your line will be going up, and if your x or m is negative, then we're going to go down, so your line's going to be going downwards. And this is all talking about the gradient. So for example, i.e. if I had 3x, 5x, 7x, these are all positive x's, or even just single x, then they are all positive. For negative x's, if you have minus 3x, minus 4x, minus 8 over 3x, or just minus x, then they all show negative gradients, so then your line will be going downwards. And like I said, where the line cuts will be the x-axis. So for example, if I drew this purple line, well, this is going to have a positive x, so I could say it's got 4x. And if this number here is 8, then that's going to be plus 8. If I drew a diagonal line going in the opposite direction, so like here, then this is going to have a negative gradient, so let's say minus 6x. And if this value here was, let's say, minus 1, then this number here would be minus 1. So any equation that has a single x or a single y will always be represented by a diagonal line. And then depending on how far you want to take of what it should look like, again, that's when you need to start looking at the gradients, and you need to start looking at the y-intercept and start focusing on y equals mx plus c. So let's focus on the main point of this video, which is actually drawing and plotting a straight line given its equation. So to draw a line, you need at least 2 coordinates. However, it is always advised to have at least 3 coordinates to help identify any miscalculations. So if you imagine if I drew 2 points, well, you only need 2 points to draw a straight line. Because obviously if I only had 1 point, then it could be this line, it could be that line, it could be that line, whereas 2 points give me a distinct reason. Now, the reason why we go for 3 points as a bare minimum is because if you were to plot them, as you can see with these 3 green points I can plot there, they don't quite make a straight line. So one of the points is at least wrong. So it helps me identify whether I've made a mistake. Whereas if I had, let's say, points that went straight in a line, then I'm saying, yeah, definitely that looks correct, so I'm just going to go for it. Now, to find these coordinates, now obviously we need at least 3 coordinates. So to find these coordinates, you need to draw what we call a table of values. Now, a table of values looks like this. So what we do is you make up, or you can choose 3 values of x, in which I probably advise that you go for 0, 1, 2, because they're probably the most nicest numbers to work with. And then what we then need to do is substitute these numbers into the equation to work out what our y ordinates are. So it's these columns that will give us our coordinates. Now in exams, this table will be given for you to complete. However, you may need to make your own for textbook questions or higher marked exam questions. And if this is the case, I would always go for 3 simple values. And like I mentioned, 0, 1, 2, or 3 as your x values. So finding the coordinates and plotting. So as mentioned, in order to plot an equation, you need coordinates. So to get these coordinates, all you need to do is simply choose x values to substitute into the equation to find the respective y ordinates. Now, ordinates is just the y values of the coordinates. So for example, if I had 4, 5, then 4 is my x ordinate and 5 is my y ordinate. And together they join to make coordinates. So, and by completing the table, we can then have our coordinates. So for example, in this particular thing here, so to find the y ordinates, what I need to do is I start with x. I'm going to multiply it by 3 because that's where the 3x comes from. And then I'm going to take away 2, and that's from the -2. And that's going to give me my y values. So looking at this, and this is one of the reasons why we deal with 3 small numbers. So 0 times 3 is 0. Take away 2 gives me -2. 1 times 3 is, let's just write that down. So 0 times 3, take away 2 is -2. Then for the next value, I'm going to do 1 times 3, take away 2. 1 times 3 is 3, take away 2 is +1. And then for my third value, I'm going to do 2 times 3, take away 2. So 2 times 3 is 6, take away 2 is 4. And what I've now got are my 3 coordinates that I then need to plot. So this coordinate here is 0, -2. This point here is 1, 1. And this point here is 2, 4. And these are the 3 coordinates that I now need to plot. So with a set of axes, and again, just quickly making a quick note before the coordinates disappear off the screen, and I'm plotting y equals 3x minus 2. So what I'm now going to do is plot these coordinates. So again, the usual things of plotting coordinates comes into question. So you always go across and then up and down. So I've got 0, -2, which is here, 1, 1, which is here, and 2, 4, which is here. Now from this, you should always have a glance and think, right, okay, do those 3 dots make a straight line? Well, I'd say yes. Now again, breaking this equation down. Now if we then join these 3 points, now I'm going to be a little bit more accurate than I usually am, and I'm actually going to use a straight line to actually do this, and I'm hoping that this will therefore work. There we go. Oh, and let's just make that so it goes through the points. There we go. Now from this line, you want to try and be as close as possible. Obviously, hopefully you're going to be, it's going to be a lot easier working on paper than it is on the computer. And this line here represents y equals 3x minus 2. Now from this, we can then just take a little brief glance at thinking, does this line look correct? Well, I've got a positive gradient. So is the line going in an upwards direction? Well, yes, it is. Now looking at this point here, does the line cross the y-axis at -2? And yes, it does. So that's another tick. So there's a good chance that I've got this question right. Now when plotting, what you want to try and do is always extend the line. So always extend the line beyond your plotted coordinates. Now what I mean by that is if I had 3 points here, so let's say I've got these 3 points here, that I'm not just going to join those 3 dots there. What I'm going to do is I'm going to take that line and I'm going to make it a lot bigger. So it goes beyond those 3 points. And you definitely want to draw your line so that it crosses both axes if it's possible on your diagram. Obviously you don't want to go into another classroom or into another bedroom or room, wherever you are. So let's have a look at some example questions. Now these are some example questions that are taken from exam papers and taken from different websites, but hopefully they're going to be very, very familiar to the types of questions that you're most likely to get either in class or for homework or in an exam. So looking at these particular questions, it says on the grid, draw the line x equals 3. Now x equals 3 is going to be a vertical line through 3. So what I need to do is get my ruler or a straight edge, and I'm going to draw a straight line through 3 and a vertical line at that. Now like I said, it's always good practice for you to extend your line beyond that, so I can then label this as x equals 3. Then for the next line, which I'll do in green, so y equals a number, well that's going to be a horizontal line through +1. So again, I've got +1, so again I'm going to get my ruler or a straight edge and I'm going to draw a horizontal line through that. And again, very good practice for you to extend your line just a little bit further so it does cross both axes, or one of the axes I should say in this case. So here we've got y equals 1. Now the question is then asking for write down the coordinates of where the two lines meet. So I'm looking for this coordinate here. So again, I'm going across first, so that's going to be 3, and then I'm going up 1, so the coordinate then is going to be 3, 1. So then moving on to the next question. So again, this is where they've already given us our table of values. Now, as I said, if you get free choice, you can choose 0, 1, 2 or 1, 2, 3, whichever floats your boat. But sometimes you might be given specific values for you to substitute in, but it works exactly the same. So what you need to do is look at the equation, and then what you then need to do is convert it to work out how you actually work out the y ordinate. So for this, we're going to start with x, and all we're going to do is we are going to add 2, because we're not multiplying anything because we've just got 1. So we're just going to add 2, and that's going to give me my y values. So minus 5 plus 2 is minus 3. 0 plus 2 is 2. 3 plus 2 is 5. So these are the coordinates that I now need to plot. So I need to plot minus 5, 3, 0, 2, and 3, 5. So plotting those coordinates, I've got minus 3, 5, minus 5, 3, which is here. I've got 0, 2, which is here, and 3, 5, which is here. So again, I make an avid sort of look to do those 3 points, make a straight line. Yes. So then we can go straight into actually drawing that line. So again, trying to be as accurate as possible and making sure that they do go, in fact, through the 3 coordinates. And there we go. Now again, just a quick check. Does this line, does y equals x plus 2 supposed to have a positive gradient? Yes, because my x is positive. Does the line cross the y-axis at plus 2? Yes, so there's a very good chance that I have done this correctly. And again, B, drawing the straight line is pretty much done. So moving on to a very, very similar question. So again, to find the y ordinates, what I need to do is use this formula. So x, starting with x, what I need to do is I now need to do 2 take away x. So for this, what I need to do is starting with x. So let me get rid of this. So to find this particular value, what I need to do is do 2 minus, and then whatever the x value actually is. So it's going to be minus 3. So here, 2 minus minus 3 becomes 2 plus 3. So then that's going to be 5. For the next value, for this, it's going to be 0 minus, 2, confusing myself. So here I'm going to have 2 minus, and then whatever number this is, which is 0. So then that's just going to give me 2. And then for the last one, I'm going to have 2 minus whatever number this is, which is 5. And that's going to give me an answer of minus 3. So next what I need to do is plot these coordinates. So I'm going to plot minus 3, 5, 0, 2, 5, minus 3. So again, plotting those coordinates, minus 3, 5 is here, 0, 2 is there, and 5 minus 3 is here. Now again, think to yourself, does that make a straight line? Yeah, I'll say it does. So again, using a straight edge, what we're then going to do is plot that line. And like I said, when you draw your line, it should go through all the points you've plotted. And then again, using your common sense and your analysis of reading the equation. So here, have you got a negative x? Well, yes. And also the line is going downwards, so that's correct. And does the line cross the y-axis at 2? And yes, it does. So again, looking good that I've got this one right. So again, moving on to another similar question. So again, looking at the equation. So again, we've got 0, 1, 2, which is probably my preferred choices of coordinates we've got. So again, I'm going to start with y. I'm going to start with x. And I'm going to multiply it by 2 and then take away 3, and that's going to equal my y ordinates. So starting with this, I've got 0 times 2, take away 3, so that's going to give me minus 3. Then for this one, I'm going to have 1 times 2, take away 3, which gives me minus 1. And for this one, we're going to have 2 times 2, take away 3, which gives me positive 1. So my coordinates are 0 minus 3, 1 minus 1, and 2, 1. Now, do you need to write these coordinates out? Not particularly. If you're good enough to recognize that these are the coordinates, but just written vertically, then that's going to be absolutely fine. So 0 minus 3 is here, 1 minus 1 is here, and 2, 1 is going to be there. Again, do those 3 points make a straight line? Yes, they do. So again, all we need to do is draw a straight line through those points, and we go from there. And again, just checking, we've got positive gradient and it crosses through minus 3. So again, there, that's looking all good. So again, moving on to another question. So here we haven't got a table of values, so we actually need to do this ourselves. So starting off, I'm doing it over here. I've got X and I've got Y, and I'm going to pick, and again, you don't have to pick 0, 1, 2. You could go 1, 2, 3, but I certainly would pick numbers that are on your graph if you're given one. It just makes it a whole lot easier. So from this, we can then, choosing 0, 1, 2, 1, 2, we're going to substitute it into the formula. So y equals 4x minus 1. So what this is timesing by 4, or multiplying by 4 I should say, and then take away 1. So 0 times 4 is 0, take away 1 is minus 1. 1 times 4, take away 1 is 3, and 2 times 4 is 8, take away 1 is 7. Now with this, you just need to be careful that with your y ordinates that they are going up in 2s, so you might have to plot halfway through a line. So 0 minus 1 is going to be here, 1, 3 is going to be here, and 2, 7 is going to be there. Now again, you just need to be a little bit accurate. This one's going to be a little bit sort of sketchy, but we'll do our best. And so let's just join those points up as best that we can, like so, and I'm just going to extend that line like we mentioned. There we go. Right, now in terms of question B, it says use the graph to estimate the value of x when y equals 1. Now for y equals 1, that's going to be a horizontal line through 1. So what I need to do is draw a horizontal line through 1. And what the question is asking me is to say, what is this number here going to be? Now for this, what we need to do is roughly state what this number here is going to be. So I would say it's pretty much going to be x equals a half. Now you could work it out. So again, I could easily, in terms of simplifying this, of equaling 1, so I've got 4x equals 2, so x equals a half, and that's you solving the equation algebraically, but they're not wanting you to do that. They're just wanting you to say, what is this value? And if you've drawn it correctly, that an answer of a half would be absolutely fine. If you wanted to go to decimals, that's absolutely fine, of 0.5. There would also, because you're using a graph, depending on your plotting, if you were to go either or, quite close to 0.5, so let's say 0.4 or 0.6, they may give you an extra mark, but the correct answer you should have, if you've drawn it correctly, you should recognise that it's exactly halfway between 0 and 1, and writing the answer of 0.5 or a half. So moving on to the next question. So here we're going to have quite a tricky equation here. So here we've got a negative x, which means that the line is going to be going in a downwards direction, and it's going to cut the y-axis at 6. So again, a lot of numbers for me to fill in. So here what I need to do is, so for this one, what I'm going to do is it's going to be 6 minus 2 times 0. This one here is going to be 6 minus 2 times 1. This one here is going to be 6 minus, oh, I don't know why I've put loads of brackets there. Let's get rid of them. So here, this one's going to be 6 minus 2 times 2. This one here is going to be 6 minus 2 times 3. And this value here is going to be 6 minus 2 times 4. Now, if you want to write them down, that's fine. If you can do it in your head, even better. But you want to make sure that you are getting these numbers correct. So 6, so this is going to be 2 times 0, which is 0. 6 take away 0 is 6. 2 times 1 is 2. 6 take away 2 is 4. 2 times 2 is 4, 6 take away 4 is 2. 2 times 3 is 6, 6 take away 6 is 0. And 2 times 4 is 8, 6 minus 8 is minus 2. So now, again, I've got my coordinates. So I've got 0, 6, which is here. I've got 1, 4, which is here. 2, 2, 3, 0, 4, minus 2, and 5, minus 4, which is here. And then again, all I then need to do is draw a straight line through it. And there we go. And let's get a different colour. And there is my line. Now, if I just get rid of all this working out, just so I can read question C correctly. So here it says solve 6 minus 2x equals 3. Now, it's not asked me to solve it using the graph, but it's kind of implying that I do. Now, this part here is y equals 6 minus 2x, and that's basically the purple line. Now, if I look at, let's get a different distinctive colour. Now, if I plot y equals 3, well, that's going to be a horizontal line through 3. So 3 is here, so I'm just going to draw a line of y equals 3. And again, I should be using a ruler. And what the question is asking me is to solve this equation. So what they're looking for is, what is this number here? So looking at the graph, then this answer is going to be x equals 1.5 or 1.5. And there we go. Now, if it was an algebra question, because it's not really said for me to use the graph, then what I could do is either take the 6 over to the side. So I've got minus 2x equals 3, minus 3 rather. And then I've got x equals minus 3 divided by minus 2. So x equals 3 over 2 or 1.5, which is exactly what I wrote down at the start here. So this is solving the equation algebraically, but it's just kind of showing you that my graph gives me the same answer. So moving on to the next one. So again, here we've got much more complicated equation to work with. So I've got y equals 3 minus a half x. Now again, breaking this down, I know it's going to be going downwards because I've got a negative gradient, because I've got minus a half, and it's going to cut at y equals 3. So it's going to go through this point here, and it's going to go in a downwards direction. So looking at the points, I've got x and I've got y. Now, you can use 0, 1, 2, 3, 0, 1, 2, and that's going to be absolutely fine. But if you are thinking a little bit smart, you've got to think to yourself, what are you doing to x? Well, I'm going to be dividing it by 2. And you've got to think to yourself, what are the best numbers to divide by 2? Well, the best numbers divided by 2 are even numbers. So I could go for 0, 2, 4, just to make my life a little bit easier. So looking at this one here, it's going to be 3 minus, and it's going to be a half times 0. So a half times 0 is just 0. So it's just 3 take away 0, which is 3. For this next one, I've got 3 minus a half times 2. Now, a half times 2 is basically the same as 2 divided by 2, which is going to be 1. So here I've got 3 minus 1, which is 2. And then finally, for this one, I've got 3 minus a half times 4, which is the same as 4 divided by 2. So that's going to give me 4 divided by 2. So it's 3 take away 2, which is 1. So looking at the points, then I've got 0, 3, which I've already made from my knowledge of the equation. I've got 2 at 2, and I've got 4 at 1. And again, do those points make a line? Yeah, I would say that they do. So all you need to do is use a ruler and join those points up. And then once you've done that, what you then want to do is remember to try and extend your line. No, don't just go through the coordinates that you've plotted. What you want to do is extend that line so it goes beyond. There we go. Moving on to the next example. Now these ones are a little bit more high level and do require a little bit more sophistication. So if you've mastered all the previous examples, you want to kind of challenge yourself, then these are the types of questions that you're likely to get asked near the end of your exam or at a much higher level. Now for this, we haven't got y equals, so it's really difficult for me to kind of initially say, where is this going to cross the y-axis? What is the gradient going to be? Now, the tactic for this is trying to work this out. Now, I personally would make one of the letters the subject, try and get one of the letters equal to the rest of it. So for example, you want x equals or y equals. Now, typically with every single question that we've done, we've got y equals. So here we've got x plus 2y equals 7. Well, if I take the x over to the other side, I'm going to end up with 2y equals 7 minus x. And then if I take the 2 over to the other side by dividing by 2, then I've got y equals, and then 7 divided by 2 is 3.5 minus x over 2. Now for this, it's going to be a little bit more complicated. So all I now need to do is work out these values and substituting it into this formula. So to work out this value here, I'm going to do y. Well, let's go for y equals 3.5 minus 2 divided by 2. This value here is going to be 3.5 minus 1 over 2. This value here is going to be 3.5 minus 0 over 2. And this number here is going to be 3.5 minus 1 divided by 2. And this value here is going to be 3.5 minus 2 over 2. And finally, this number here is going to be 3.5 minus 3 over 2. And again, you can use your calculator to work them out, and then you can go and you'll find out your values. Now, another way of you working out is to actually substitute the numbers in. So again, if I work over here, I've got x plus 2y equals 7. Well, if x is minus 2, so let me just write, so if x equals minus 2, then I've got minus 2 plus 2y equals 7. And what I can then do is work this out. So I've got, take the minus 2 over, so I've got 2y equals 9, and then y equals 4.5. So this value here is going to be 4.5. So more difficult questions are going to involve decimal answers. And again, it's entirely up to you which one we're going to go for. So this one here is going to be 4. And the next one is going to be looking at 3.5. So you can see now with this, you can see that the numbers, now again, this is what I mean by about being smart. You can see that the numbers are going down by minus 0.5. So without having to do any form of working out or any of these sort of calculations that we've been asked to do, I can kind of be a bit smart and think, right, okay, well, I'm just taking away a half from each one. So the next one's going to be 3, then it's going to be 2.5, and then it's going to be 2. And then what I can then do is plot those coordinates. So I'm going to plot these points. So minus 2, 4.5 is going to be here. Minus 1, 4 is there. Minus 0, 3.5 is going to be there. 1, 3 is there. 2 and 2.5 and 3, 2 is going to be there. So the last thing for me to then do is join those points up with a straight line, and which I can do that like so. And there is my equation. Now moving on to this next question, very, very similar, but again, a very popular question that comes up. Now if you're struggling to see that that equation there is x plus y equals 6. Now for this, what you're doing is we've been given the x values, and you just need to think to yourself, well, what do you need to add to x to get 6? So 0 plus what gives you 6? So that's going to be 6. 1 plus 5 gives you 6, that's fine. 2 plus what gives you 6? That's going to be 4. 3 plus what gives you, so again, it's your x plus question mark equals 6. 3 plus what gives you 6? That's going to be 3. And 4 plus what gives you 6? That's going to be 2. So then once you've got this, you can then plot your coordinates. So I've got 0, 6, 1, 5, 2, 4, 3, 3, and 4, 2. And again, just be wary of the numbers on the scale. So here my bottom axis is going up where 2 squares equals 1, but on the opposite, on the y scale, it's going up in 1s, but the scale is labelled going up in 2. So just be mindful of that. And again, all I then need to do is draw my straight line, going through those all those points as best that you can. And let me just alter that one. There we go, perfect. And again, what you want to try and do is make sure that you extend your line beyond the points that you have plotted. And then finally, let's have a look at this one. Now this one we've been given zero information. Now we haven't been given a grid, we haven't been given a table, but what the question does say is actually given us that it wants us to do our table of values from the values of -2 to 2. So for this, what I need to do is set up my table of values, and I've got -2, -1, 0, 1, 2, and I need to find out the respective y ordinates. A table of values doesn't need to be ridiculously neat, but it does need to be big enough for you to actually write numbers in. So for this, what I'm going to do is I've got my x values, I'm going to multiply them by 4, and then I'm going to subtract 5, and that's going to equal my y values. And again, how I've got those values is from the equation. So -2 times 4 is -8, and then take away 5. I don't know why I put minus 5, so let's just get rid of that. Oh no, it's not -5, it's just take away 5, and can't read my own handwriting. So here we've got -2 times 4, which is 8, take away 5, which is -13. Then I've got -1 times 4, which is -4, take away 5 is -9, and then 0 times 4 is 0, take away 5 is -5, and then 1 times 4 is 4, take away 5 is -1, and 2 times 4, which is 8, take away 5 is 3. Now again, being a bit smart, you can see, well, the numbers are going up by 4. So once you've worked out the pattern, you don't have to do the substitution, you can just go from there. Now one of the biggest things that students get get confused about is drawing a scale. Now this is typical of when you're in a classroom and you're having to plot these in your exercise book, is how do you know what scales to use? Now, looking at the axes, my x values, so this is the numbers that I've got to go across. Well, the smallest number is -2, and the biggest number is 2. Now, for the y values, which is going down, that the smallest value is -13, and the biggest number is 3. So what I need to do is I need to then make sure that my scale includes those numbers. Now, 3 to 13 is quite a lot. So what I'm going to do is I'm going to start near the middle. So I'm going to start here. I'm going to start at 4 because I usually go a little bit extra. So I'm going to go 4 to -14. So I'm going to go down in 2. So I've got 4, 2, 0, -2, -4, -6, -8, -10, -12, -14. And then where 0 is, I'm going to go up in 1. So I've got 1, 2, 3, and -1, -2, -3. And again, what I'm going to try and do, now this is where it can slowly start getting a bit messy, is I'm now going to draw my axes. And let's just neaten that up a little bit, if I can. And then my horizontal axes. Now you can do your graph a lot bigger than what I've done. It's entirely up to you, but as long as you include the numbers that are in your table, then that's all that matters. Now again, the key thing also is don't forget to label your axes. It's an area where a lot of students tend to go wrong. And let me just make that the same color. Right, so once I've decided on my axes, the next thing I've now got to do is plot my coordinates. So I've got -2, 13, so -2, 13 is here. Then I've got -1, 9, which is here, and then 0, -5, which is here, 1, -1, which is here, and then 2 is 3, which is there. And then the last thing I've then got to do is to draw my line through all those points that I've plotted. Again, try and extend your line beyond the points of what you've plotted, and also just make sure that your line does go through all of your points. And that is it. So hopefully the process of plotting an equation makes sense, and you kind of gone through quite a wide range of questions that you're likely to get asked both in your classwork or your homework or in an exam, and that you now understand it. Now I will put some questions along with their answers in the description below for you to practice everything that's covered in this video.